Good day. Today we're going to go over lesson 17-2, which talks about exterior angles and angles in a quadrilateral. Our learning targets for today are: I will describe and apply the relationships between an exterior angle of a triangle and its remote interior angles. Our second learning target is: I will describe and apply the relationship among the angles of a quadrilateral. So when you walk out of the door today, there are two things that I want you to walk out knowing: how to find an exterior angle and what are remote interior angles. And then for your second learning target, I want you to walk out the door today knowing what are the relationship of angles in a quadrilateral. Okay? So make sure you can answer those at the end of the lesson. Let's begin. Let's refresh our minds from last year: angles in a quadrilateral and angles in a triangle. We know from our last lesson, in looking at angles in a triangle, we know that all angles in a triangle add up to 180 degrees. So we should know that this angle plus this angle plus this angle, when added together, is equal to 180 degrees. For a quadrilateral, we know that all four angles in any quadrilateral adds up to 360 degrees. So all four angles in any quadrilateral, and we should know a quadrilateral is a shape that has four sides. All angles in a quadrilateral adds up to 360 degrees. And we will also do an activity in class in which we will show that all four angles do add up to 360 degrees. So let me erase this. Take a look at this second figure over here. Today you're going to learn something new, and we're going to learn about exterior angles of a triangle. Notice that we have three angles highlighted here. One of them is on the exterior, which is angle 1, but we have angle 2 and we have angle 3 over here. These two angles are known as remote interior angles, and you're going to learn more about this in the lessons. This angle, angle 1, is the sum of angle 2 and angle 3. So if you're ever missing one of these, this is a theorem, and the measure of angle 1 is equal to its remote interior angles when added together. Okay? So let's move on. The exterior angle of a triangle is formed by extending a side of the triangle. The vertex of the exterior angle is the vertex of the triangle. The sides of the exterior angle are determined by a side of the triangle and the extension of the adjacent side of the triangle at the vertex. That's a lot to read, right? Well, let's go ahead and figure this out. Number 1, use triangle SRQ below. So we see a triangle in our books, and it says extend side SQ, and you notice in my picture here I already have it extended. Extend side SQ of the triangle by drawing SP. So this is going to become P right here. Let me write that better. SP through point Q to create the exterior angle RQP. So we are looking at this exterior angle here of RQP. Describe the relationship between angle RQP and RQS. Well, if I look at RQP, so that's this angle, and then angle RQS, so RQS, so we're looking at this angle here. It says, what's the relationship? Well, we should know that both of these angles are supplementary. So both of these angles are supplementary, and supplementary means that they add up to 180 degrees. So both angles are supplementary and they add up to 180 degrees. Let's move on. An exterior angle has been drawn at each of the three vertices of SBM. Determine the measure of each of the three exterior angles. So each of the measure of the three exterior angles is what we need to find. So therefore, let me go ahead and outline them. We need to find this angle, and this angle. Well, we can go ahead and find this one. Both of these angles are supplementary. So if they're both supplementary, that means I can say 180 degrees minus 54 degrees is going to equal what? I want you to pause the video and find this angle, and then go ahead and try to find this angle, and then see if you can find this angle, and then come on back. Okay, welcome back. So, in looking at these angles, if these are all supplementary, then you can see for this angle here, I knew this angle was 54 degrees, and these are supplementary, so 180 minus 54 is 126 degrees. Same thing here on my left. I know that this is a straight angle, so 180 minus 38 degrees is 142 degrees. But then when I got up here to the top to this other angle, it was a little tricky, because even though these two are supplementary, I didn't know what this angle is. And because I didn't know what that angle was, I recognize that this is a triangle. And if this is a triangle, all angles in a triangle add up to 180 degrees. So therefore, in doing my math, 180 degrees minus the two known angles in the triangle equaled 88 degrees. So this angle here turned out to be 88 degrees. And because this is 88 degrees, I can subtract it from 180 to get 92, which is what I did here. And that's how I figured out all the angles in a triangle. Okay, let's move on. And remember, you can always pause the video and go back and refresh. Now, we just did number 2 on the previous slide. For number 2B, it's trying to get you to recognize the remote interior angles of triangle SBM. So if we're looking at the exterior angle SMT, so exterior angle SMT, if I look at this figure, SMT, the exterior angle is this angle right here. And if you're going to look for the remote interior angles of that angle, you're going to find that the remote interior angles are these two angles right here, angle 1 and angle 2 for this triangle. So you can go ahead and write those in here. Then it says for exterior angle RSB. So let's do some erasing here. RSB, so angle RSB, so RSB. So we're looking at this angle right here. That's my exterior angle. So what are the remote interior angles for this angle? So that would give you these two angles right here are the remote interior angles. So you can put the names of those right here. And then, of course, following the pattern, if we're looking at the remote interior angles for this exterior angle right here, we should know that the remote interior angles are this angle and this angle. So you can write those right here. So pause the video at this time and go ahead and write the remote interior angles for those exterior angles and come on back. Okay, welcome back. So we should have our remote interior angles identified. So go ahead and identify yours and make sure that they match mine. And then let's move on to C. Chip claims that there is a relationship between the measure of an exterior angle and its remote interior angles. Examine the measure of the exterior angles and the measure of their corresponding remote interior angles to write a conjecture about their relationship. So at this point, as we talked about at the beginning of the video, and you can rewind it if you want to, exterior angles are equal to the sum of their remote angles. And let's go back and look at that formula right quick. Exterior angles Okay, so this is my exterior angle, and it's equal to the sum of its remote interior angle. So this angle right here that's next to it, that's not a remote interior angle. It's the angles that are opposite that angle that are the remote interior angles. Okay, make sure you know that definition well. That could be a vocabulary question on one of your quizzes. Now let's take a look at check your understanding. So with the formula that we just learned in check your understanding, I want you to pause the video and do number 3, number 4, number 5, and then come on back. Welcome back. So looking at number 3, using that formula to find the value of x, we notice that x is an exterior angle, and exterior angles are equal to the sum of the two remote interior angles. And in this case, 40 and 75 are my remote interior angles. So when I add them together, notice I did my work over here on the side, x is equal to 115 degrees. So therefore, x is 115 degrees. Number 4, determine the measure of each exterior angle of triangle YAX. The first thing I did when I looked at this was I filled in my missing angle to my triangle. And when I filled in the missing angle to my triangle, I found that that was 69 degrees. And I did that by subtracting the sum of the two known measures from 180 degrees. So 180 minus 43 degrees plus 68 degrees was equal to 69 degrees. And that's how I was able to find 69 degrees. Now, once I knew the measure of that third angle in the triangle, I can go ahead and find my exterior angle that's supplement to it. So this is supplementary. So if this is 69, then I can do 180 minus 69 is equal to 111 degrees. Okay? 111 degrees. Now up here, let's get a different color. This angle is supplementary, and I know that this is 68 degrees. So if I did 180 degrees minus 68 degrees, I'm going to get 112 degrees. And then this here on the bottom is also supplementary. So if I did 180 degrees minus 43 degrees, I'm going to get 137 degrees. Okay? Number 5, the measure of two interior angles of a triangle are 75 and 65. Determine the measure of the largest exterior angle. So the first thing that I did was find that third angle of the triangle. So if I had a triangle that had two angles that were 75 and 65, I'm going to subtract those from 180. And when I subtract those from 180, I'm going to get 40 degrees. So I have three angles in a triangle: 75 degrees, 65 degrees, and 40 degrees. It says find the measure of the largest exterior angle. The largest exterior angle. So if I went ahead and found the exterior angle for all of these, and for this question, for this question right here, if I just went ahead and let me write that again, 75 degrees, 65 degrees, my third angle is 40 degrees, because 75 plus 65 plus 40 is 180. And we want to know the largest exterior angle. Well, if we want to know the largest exterior angle, we're going to add the largest two angles together. And the largest two angles are 75 and 65. So 75 plus 65 is equal to 140. So the largest exterior angle is 140 degrees. Okay, let's move on. Now we're going to take a look at quadrilaterals. Number 6 says draw a diagonal from one vertex in each quadrilateral. So if I drew a diagonal in all of these quadrilaterals, it says for letter B, what is the sum of the measures of interior angles in any quadrilateral? Well, from prior knowledge, we should know all four angles in a quadrilateral adds up to 360 degrees. And I guess by having you guys draw the diagonals, they're trying to